In the immortal words of Mr. Kanye West, welcome to this webinar, Better, Faster, Stronger, Cassandra 2.0. I am delighted to have back with us Mr. Patrick McFadden. Patrick has got a new gig. So, Patrick, let's get into this and tell us what you're doing now.
I'm the chief evangelist now at DataStax for Cassandra.
Which is sort of what you've been doing as well, so
Pretty
just
much.
making it official, right?
Yeah, I think that's kind of been my role for a while, education, advocating, but this is great because I get to do this full time without having to sneak around and do it in the back, right? I never sneaked around.
we're really excited. Patrick will be able to, help many more people in the community than he has done, and that's good for everyone. So just one item of housekeeping before Patrick gets going, and that is please feel free to ask us any questions, but use the WebEx Q&A manager. Type your questions in there. We will get through as many of them as we can at the end. So take us away, Patrick.
Yeah, so first thing I did is I got the title backwards. I actually just realized that. But Better, Stronger, Faster is cool too, because it's all three words, right? It doesn't matter well, Kanye's going to have me for this, but luckily I'm not having a meeting with him anytime soon, right?
Maybe you'll get in a Twitter feud with him.
Hey, that would be really cool. And then I could throw you out. Are you eventually consistent? Never. Okay, that was a bad joke. So today, this is going to be all about Cassandra 2.0. And what I want to do is, I think maybe most people that are in the community know about Cassandra 2.0 from a top level. If you've never worked with Cassandra before, you probably never, all these are going to be new concepts. This isn't an introduction to just Cassandra. I'm going to be talking about the new things that are with Cassandra 2.0. And if you know some of what's in Cassandra 2.0, I'm going to go way deep in some of these. Some of the features that are not talked about very much, I want to give you kind of a comprehensive view of what is really there. There's some really compelling stuff. It was a big release. Obviously, it's a .0 release, and so what we're trying to accomplish here is just moving the ball forward on Cassandra as a premium database. It's the best database for your persistence tier, and the features that are now present in Cassandra really speak to that. And hopefully, at the end of the webinar, you'll feel the same way. And if not, hit me up on chat, and we could talk about it. So. First thing I want to go to is, I got to advance my slide here. Hang on. Oh. There, I got it. Okay. So 2.0, we are in 5 years of Cassandra, and that's a pretty amazing thing now. I mean, 5 years is a pretty significant milestone for anything. We've got a lot of history in Cassandra, and it shows. I mean, if you look at where a lot of early adopters landed in Cassandra world, I was right about in the middle, and this is where I was, 0.7. And I think that was really what a lot of people think is the first real production-ready version of Cassandra. A lot of people moved into it, and it had a lot of features that made it ready for prime time. And it quickly progressed. I mean, if you look from February 2011, we were on 0.7, and by the end of the year, we were at 1.0. And 1.0 was an amazing release, too, and we brought a lot of things going on. So we're just a couple years after that, here we are, about a year and a half, we're into 2.0, and so let's talk about what's going on in that version. So let's talk about the big features first, and these are probably the ones that people have heard about, but I'm going to just highlight these and talk about them a bit more so that we have a comprehensive view. So what I'm looking at here, I was going to start out with the lightweight transactions. Now this is originally known as the CAS or check-in stat, but lightweight transactions as a feature are to solve a particular problem the Cassandra database has had for a long time. And it's the edge case that we're looking at here. The edge case is what happens when you have a race condition. So here's my situation that I'm trying to solve. In my session, I have 2 different sessions, maybe web sessions going, and I have 2 users that want to use the exact same username. Now, this is a classic problem of, hey, I want to make sure that one wins and the other one doesn't overwrite the other. Well, before we had lightweight transactions, let's say I had 2 people with the J. Bellis. Who'd that be? Jonathan. We had the same username on 2 different web sessions creating user accounts. Well, before CAS, you would have to do a read on the database. Both would come back with an empty result set saying that you don't exist. Let's say this is happening at the same time. All right, now it's a race. Who's going to set it first and who's going to set it last? And with last write wins as a concept in eventually consistent database like Cassandra, what's going to happen is, let's say the left one does its write first with a username and a password, and then the one on the right, a few milliseconds later, does its write to the database. And when that happens, who wins? Well, it's going to be the right one. And my little picture there shows you, like, yeah, so one's going to stomp on the other one. So this is going to be confusion city. This is a classic problem of race condition that is really difficult to deal with. And up to this point, we have a lot of creative solutions out there on how to deal with this in a distributed system like Cassandra. So we want to solve that problem. So how do we do that? Well, the classic is using some sort of locking algorithm and external locking algorithm. There's actually a few recipes out there for people using Cassandra that use something like external locking, like, say, Zookeeper. And that kind of makes me sad when I hear people use Zookeeper because it opens up yet another edge case. Because here's how it would be a problem. When the client asks for a lock, let's say you go to Zookeeper and say, hey, I want to lock this particular action, then when it does a write into the cluster, if there's some sort of a failure in the cluster, let's say that one of the replicas dies, well, based on the way the distributed writes work in Cassandra, the coordinator will see that dead node, rewrite the hint, and store the hint. But because it wasn't able to complete, it will time out the response. Well, that timeout is going to go back to the client. The client's like, oh, that didn't work, and we'll release the lock. Well, meanwhile, what's going to happen, when that replica comes back online, it will replay the hint, and then that data will get set. So you're outside of the locking parameters. Yes, that's an edge condition, but it's just yet another one you have to deal with, and it kind of points to the fact that doing external locking takes you away from the real problem domain, which is it's inside the cluster. The cluster needs to maintain that coordination because that's where it's happening. So what we use is Paxos for this, and this is how it was implemented. Paxos is a very well-established algorithm. It's a consensus algorithm, meaning that the servers participating in the cluster have to agree, and it's based on a quorum. And it's really just all about, hey, I want to set some information exclusively, and all the other servers say, okay, it's all yours, and then that allows that operation to happen without another operation stepping on it. So while it's in the middle of, say, writing out a record into the cluster, if another process comes along and says, hey, I want to do this too, everyone's going to be like, well, hold on, someone else is doing that. So then that will fail out that, or it will stop that transaction from happening. So that's what we want, right? We want to make sure that we're blocking things that could be a potential problem. So Paxos does that in a really elegant way in a distributed system. It's been used quite a bit, Google, other places, and it's just got a proven methodology. So the downside, of course, is that this is going to take a little bit of time. Whenever you have any kind of algorithm like this, there's no free lunch, but that's okay. We know that this isn't always going to be used. It's not 100% used. And so whenever we have people wanting to lock out, say, like whenever you have creating a user account, yeah, you absolutely do not want to, you don't want to have that happen, and you're willing to take the hit on time, because what you're going to get is 4 round trips out of this for one normal update. And so we also have to make sure that this thing is durable. What if we lose nodes? And this is totally happening in Cassandra all the time. So when you lose a node, it should be durable as well. So the consistency is always going to be guaranteed using a consistency level of serial. There's a new consistency level, and it doesn't require any kind of coordination with like an elected leader. There's no master, there's no slave. It's just a very elegant way to manage that. There's a whole lot more detail out there if you want to get into it. I put the link here. Yes, I'm going to be uploading these slides after I'm done. But you can read this blog. There's a lot of talking about Paxos. If you want to know more about it, there you go. You can really dig in. So the caution is, just use it sparingly. It doesn't have to be for every single transaction. It's new and shiny, but I would say that it makes sense in a lot of cases, but not every case. So, we're saying like 1% of your application. That's kind of an arbitrary number, but based on your application. But you can see where you have potential for this. So this is how you use it. And by just looking at the use case, you can see how this would work in your particular application. So going back to our original problem set, we have this situation where I want to set a user into the system. Well, I had to insert into users, and the part that I've highlighted now, which makes this work, is if not exists. That's pretty cool. That is something that has been in relational databases for a long time, and now we have available with Cassandra. And this works across the distributed system, across multiple data centers as well. So when you're looking at setting data into the system and you say if not exists, if that did exist, it's going to stop that from happening. And that's what we want. We do not want it to just blindly overwrite records in a database and say, sorry, that just happened, and deal with it. I mean, because that's impossible to deal with it from an application standpoint. You need to have a situation where you can check and see if something exists at all. So the same goes with an update. But what's interesting is you can use this probably more with making sure you're not overwriting existing data with something new that you don't need anymore. For instance, you can use where username equals, something like that. And if, say, like you say, username equals jbellis, but then if the email is equal to jbellis at DataStack. So I want to change the email, or I want to set the email to something else if it exists as something. Probably a bad example now that I look at it, but you're going to want to have conditions whenever you say, I want to set this based on another condition. And that's where this kind of algorithm comes in, because that will be a potential race condition that you're going to avoid. All right, next big one. The triggers is a little more controversial. That I say that because when it was released, or as it's released, it's somewhat experimental. And the experimental portion of this means that we're trying out the implementation in an interesting way, and I'll go into it in a minute, but we want people to experiment with it. We want people to look at it. So how does this work? So triggers are this is the key part that you should understand. They're executed on a coordinator before any mutation is done. So that means that whenever you go to set data into the cluster, before it actually does any writing, the trigger is executed. So this isn't after write. This is when it's before writing. And the reason that it's doing that is because if there's any new mutations, let's say that you use it to write new data into another column family, the coordinator can then send that data as one packet instead of having to do multiples after the fact. This makes it atomic. It makes sure that it's all going to happen or it's not going to happen. And that's pretty critical whenever you're doing something like building indexes with a trigger or something like that. The other thing that you need to know is that you're compiling code, and you have to deploy a jar on each server. It makes it a little more onerous. You can understand why that might not be exciting. Really, it's the implementation right now. It's not really I don't think it's the final implementation at all, but it really makes it so that you have a lot of control over this, but it's meant to be for people who just want to really understand how triggers work. And so, again, this is somewhat experimental, and the way they implement it is kind of showing that. So simple syntax, create trigger, and whenever you say create trigger on, or you create a trigger name on a table using a certain class name, that class name is what you're providing. You're going out there and creating this code. Same with the drop. Drop trigger, get rid of the trigger out of there. The triggers, the implementation, you are implementing iTrigger, and iTrigger is class that we provide, you'd have to use our jar, but what you're doing is you're doing it directly against these row mutations. So, yeah, like I said, it's not for the faint at heart, but I think that the more technically minded early adopters type people will do this with that in mind, and we want to think about what the final implementation should look like and see the use cases. So if you're interested in triggers, go out and try this and let us know. Give us some feedback. We have Jira that we would love to hear from you about, the user mailing group, IRC. We want to know what you're using it for and how it works. There's a bit of an experimental edge to this, of course, that you're actually you're running arbitrary code on a server. It's not sandboxed. We haven't sandboxed this. So just be careful. If you put a do while loop in there forever, you just created a nice little sinkhole for your server. But that's just part of the implementation right now. We'll see how it goes, but we expect changes. It will change as we go along. So now, my favorite topic, CQL. We have this is the third big new thing is the CQL improvements that are coming. We have quite a bit of new things that are probably well, some of them you've already seen about lightweight transactions, like the if exists. That's kind of cool. But also some pretty useful features that people have needed for a long time with CQL that we're just missing. So the first one is this alter drop, and alter drop is interesting. I didn't think a lot of people knew this, but you can't remove a field from a CQL table in 1.2. You have to just leave it, and it doesn't take up any storage space, but I mean, still, that's kind of lame. So that's fixed. And when you do a drop, and I've highlighted the syntax, on a particular field, it also deletes the data in that field. Now, the data deletion itself is done lazily through compaction. So when you say drop this field, it doesn't immediately go out and do an erase. I remember back in the day when I ran Oracle, if I dropped a field out of a relational table, man, that would just get crazy, because it would all of a sudden drop all these, it'd do a lot of redo log and cause all kinds of load on my server. So that was something I would do like late at night or even offline. This is not that. It's almost a free operation, because it's just going to manage it all through compaction. And as you know, compaction in Cassandra is something that happens all the time anyway. So think of it as like a tombstone or something like that, where it just gets done in the background. The other change here, and this is conditional as well. This is actually using lightweight transactions in the back end as well, but it has to do with schema changes. And this is going to be more of a housekeeping thing. So let's say when we go to create a key space, if you try to create a key space that exists, it will come back with Cassandra will come back with an exception, and that's just an exception you could avoid with just a subtle change in the scheme, or in the way we do our create key space. And if you put this if not exists, then now what happens is it will create it, or it'll come back and say that it already exists. And it's just a cleaner implementation of that. But it's also making sure that when you do concurrent schema changes, that there's no one stomping on you. Same with the create table. The create table aspect is all about, I don't want to overwrite what I have in there, and if it exists, then don't do that. And dropping the key space as well. So these are, like I said, these are minor features, good housekeeping updates, but pretty much needed. I mean, it makes the language a lot easier to work with. And speaking of housekeeping, just making CQL a lot better to work with, easier to work with. Aliases, and been in SQL in the relational databases forever, but this is a great way to make your CQL look a lot cleaner. As you may or may not know, there are functions. There are functions inside of CQL. Like, for instance, the date of. So if you have a created @ and it's a timestamp, if you grab just created at, you'll get the timestamp the numerical representation of that. It's not the actual nice looking formatted timestamp. So the function date of will take a timestamp, which is a millisecond thing, and kick it out as a nice looking formatted date. Well, if you were to do that with 1.2, the name of the column as you display it on the screen would be date of and then bracket created at. And that just doesn't look very nice. So creating aliases gives you a nice clean looking, pretty output, but it also lets you do some interesting things, I'm sure, especially when you use functions like this. So any of the functions, actually anything can be as and then the alias right after it. Again, really more for syntax and cleanup, but it's just one of those things that's just nice to have now. And I think probably people expected it to be there in 1.2, so it's great that it's in 2.0. So the other really big CQL improvement is this whole, we have a lot going on with prepared statements, especially with the Java driver, but one of the things that have not been there is being able to put a TTL on something like a prepared statement bind on limit or TTL. And that, that's not probably a showstopper for many, but it makes sense to make a complete implementation of prepared statement, meaning that anything that can be a variable, a parameter, should be parameterized in a bind. So in the cases where you may have a variable limit on something, when I talk about time series data is all about managing how the data layout is inside your partition. But then, as many of you know through my data modeling series, I'm a very big advocate of using reversing time series data and using limit to find the number of events you want to pull out. So like let's say that I have an application that can pull out the last 5, 10, or 20 different events. Well, being able to parameterize that in a prepared statement allows me now to use a prepared statement for those kind of random type bind queries, but get the power of a prepared statement, but also be able to bind in things that would be done at runtime. So let's say I take a value from a web application, like 5, 10, or 20, and just pass it through as a bind variable. Great. That's going to make my programming life a lot easier. Same with TTL. Maybe I want to put a variable on how long I want that data to exist in my database. And making that a parameter is going to make it so that when I create my prepared statement, my single statement, I'm done. As a programmer, I create my one statement, I bind it into a prepared, and then I just bind that TTL when I need to at runtime. And it's just going to be a lot cleaner implementation. Makes a lot of sense. And so I think that these are, they look minor, but they're going to be very helpful for when you're writing your application code. So that was kind of the big feature set, but I call these minor features. I guess that's kind of a misnomer. There's some really cool features in here, and I get excited about these smaller features because they have a big punch. And I'm really all about performance when it comes to data modeling, working with customers. I do a lot of consulting, of course, and I'm sure a lot of you know me from that, where we're just trying to squeeze milliseconds out of our database, and everything counts. And so there are some really nice new things in here that's going to help this story. So let's talk about those. So in query performance, and this is my exciting part, and these are not talked about very much at all, so I'm glad I get a chance to. So the first one is a hint. We now do hints when reading time series data. Now, when you're reading time series data, it's just that. I want a beginning time and an ending time when you do a query on time series. That's usually the case. It's a slice of data across a certain amount of time. Now, when you're asking for data from Cassandra, the ultimate thing is it's going to go to an SS table, meaning the data is sitting in a file somewhere on your file system. The less you have to go to the file system for your data means less potential seek time on the disk and a lot better performance on your query. Well, so here's a funny little thing, is that when you're using time series data, we can use that in a way that will give a hint to the queries. And when we're compacting data or flushing it out to disk, we create indexes already on things like start and end of different terms that's inside the storage row. So now what we have is it actually looks at the time series portion of that as well. So this is just a hint, but when you ask for a slice of data for a particular storage row and it's time series data, we can get an index interval on that so we can get it faster. And that's the name of the game. We're trying to get to an SS table faster with your data, so it minimizes the seek time, you get your data faster. And with time series data, we already have a pretty good idea. It's a fixed type, and it makes a lot of sense to have that. So what I would expect is that as you work with time series data in the future with 2.0, that your range queries are going to be a lot more efficient. And I'll be talking about how to measure this type of performance using something like CF histograms at the summit, the Cassandra Summit in London here in a few weeks. But you're going to see that there. When you look at your CF histograms, you're going to see those numbers drop like crazy, and that's good. That's what I always try to advocate when people ask me about performance. Do that. It will make your life better. The other level compaction is probably the least understood compaction strategy out there, but one thing you should know about it is that the various levels contain certain numbers of files, and this can be a condition that can get aggravated if you have, say, really bad disk I/O or something really bad going on in your server. Each one of those tiers, like level 0, level 1, they all have the need to move files or do compaction to move data up through the levels. And if the level 0 gets behind, it's going to take a long time to recompact all that data, and it's very aggressive compaction. So the end result is if it gets behind really poorly, then it will start really impacting your read speed. And this is a problem that is just exacerbated by, say, poor disk performance. And the fact that leveled compaction is very aggressive on the disk. So we kind of have two things working against each other. So what this new feature will do is when you start falling behind that bad in level compaction, Cassandra will switch it over to using side tier compaction, which is less aggressive on the disk, more efficient in that regard, not the same guarantees as level compaction, but you're compacting data, and that's important. And that's going to really reduce your read latency impacts whenever you're having bad disk moments, and let's face it, we all have one of those. But it's really meant to be like a way to keep things moving in the worst conditions. And again, kind of keeping in tune with what variable things are happening on your particular cluster. Next one, off-heap memory speedup. This is really a great feature because there's so much stuff going off the heap. Now, let me just quickly, so to catch people up on what I mean when I say heap, off heap. Cassandra runs in a Java virtual machine, and the memory inside that, of course, is the heap. That's what we call the Java heap. And way back in the day, when you go back on my little time series graph, or my time graph there, when Cassandra was early on, all of the memory that was managed by Cassandra or needed to be used by Cassandra was inside the Java heap. And if you look at the way Java heaps are managed, they can be very small in comparison to the rest of your server. We recommend 8 gig heap. If you have 24 gigs or 64 gigs or 128 gigs of RAM on your box, you're not going to see it inside the Java virtual machine. But that doesn't mean you don't need that kind of memory. So as we went along through the history of Cassandra, more and more things were moving off the heap, meaning that the Java virtual machine then addresses memory on the main memory of the box itself. And there's a way that it does that, there's some libraries that do that very efficiently, but it's moving a lot of data. Well, there was some refactoring done. It's a great ticket, but basically moved that, got 10x speed on just making some pretty significant changes to the way it does it. And that's significant because 10x is pretty good, especially when you're moving gigabytes of data. So that, small feature, small patch set, but man, it's going to have some punch, and I'm really excited about this because we are moving a lot of stuff outside of the Java heap. Metadata, compression metadata, row cache, the key cache, all these things are outside of the heap now. And so moving it in and out of memory really fast is really important. So this is a good one. The other one is removing this kind of poorly used feature of, and I'll just kind of glance over this a bit because it just goes into a lot of details about how bloom filters work. But essentially bloom filters are there to help you find data. And by that, it uses a probabilistic algorithm to say where my data is not. And it's an expensive calculation, but it also consumes data. It consumes disk space, it consumes memory to store that filter. And we had row-level bloom filters that were there to help find data inside the storage row, but they never really were used to good effect. It never really became a good performance thing, and it really just turned out to be more overhead than it was worth. So those have been removed, and that's one of those things that, okay, now that we've got rid of it, I think we'll be better off and no one will care. So that's going to help query performance quite a bit, especially with large storage rows, because we won't have as much bloom filter getting in the way of those. How am I doing for time? Excellent. All right, so on the server side, now this doesn't manage, everything manages on query speed, but this is more of an operations thing. So on server performance side, single pass compaction. And again, one of those things where if you never had this problem, you don't even care. But essentially what happens with compaction is that we want to try to compact one time, meaning that when the compaction runs, it reads in the SS table, the storage row, and it spits out the compacted merge-sorted version of it. If the storage row, it gets larger than, say, the default size of 64 meg, then it has to do it twice, or 3 times, or 4 times. And that's called an incremental compaction. And incremental compaction can just be inefficient because it's just going to churn away on those really large rows. And it's going to suck up memory, it's going to suck up CPU. The single pass compaction eliminates that problem, and that is so cool because now the hit is no longer there whenever you're not having to toggle or worry about the size of data on a storage row, which is one of those little details that I don't really feel like everybody's going to have to pay attention to all the time. And now you don't as much because the impact is not there. So single pass compaction was one of the ones that I was really excited about because when I work on tuning discussions, and this will eventually manage your query tuning as well, I do look at that. And if you've ever been on a call with me or I've been on site with you, then you'll know I look for that. I don't want to have multi-pass compaction, but now we have single pass. Those of you using Thrift, LMAX Disruptor, it's a really cool name. It sounds like a character from Mad Max. The LMAX Disruptor is this whole thing about these concurrent thread performance inside Java, and it's a separate body of work outside of Cassandra, but one of our committers picked it up and used it as part of our HSHA Thrift implementation. Now, HSHA, if you use Thrift, is a half-sync, half-async implementation, which is very good if you have a lot of connections going to your hundreds or maybe thousands of connections to one particular server in your Cassandra cluster. Thrift has a lot of overhead on it because it's an RPC call. Well, with HSHA in 1.2, it lowers the amount of overhead. Now with LMAX Disruptor, it really lowers the overhead. So in these really highly concurrent, massive number of connections from Thrift, this disruptor has really made it a lot better. And it lowers the impact on the operating system, and it increases performance, which is always a good thing. So some of the numbers that came out of this were just insanity, and that's awesome. I'm looking forward to this turning into more things as well. But right now, that's available if you're using Thrift and HSHA. You should really look into it, especially if that's one of the things you're doing. And if you have any questions about it, feel free to hit me on Twitter. I mentioned before the off-heap processes. Again, more optimization with that. So we had pretty much just we had one way of doing allocation of memory outside of the Java heap, and that was with malloc, which is a common library call in Unix. But there are a lot of other implementations. Well, and some of them are better for a lot of reasons in the way they fragment memory and the way that their efficiency and speed. So we wanted to have that as an option because actually it started with one of our committers wanted to use JE-malloc, which is a different version of a malloc that it has a lot of benefit. Well, we've turned this into a pluggable thing. A lot of things in Cassandra are pluggable, and that's great because that gives you choices and it'll fit your use case. Well, in this case now, when memory is being used off heap, that is now pluggable as well. And so the allocator that we're defaulting to with that is the JE-malloc, and it's just about using faster access, but really efficient too. When you have a lot of data moving in and out of your on your OS memory, it's going to have a lower footprint, and that's good because moving data is costly based on size, and less size, faster. Those of you using level compaction, and it's funny because I actually got a tweet about this last night. Is somebody asked me, and I actually got this wrong, so I'm going to have to put a correction in here. Somebody asked me, like, if you're using level compaction, what would you set your minimum size in megabytes for your level 0? And those of you not familiar with level compaction, it's really about the first file that's created in level 0. Level 0 is the first tier of data in level compaction. The default was 5 megabytes before. Yeah, that's megabytes. This is puny little files. And so what would happen is you get just tons and tons and tons of these little files. It wasn't efficient because we were compacting things too fast. I said 256. That's wrong. It's 160. So ignore my number. I'll fix it before I put it up on SlideShare. But it's 160 megs. It's now that's a big difference between those two. And the reason is because someone did some performance analysis and did different sizes and found that 160 was a nice sweet spot. It kind of balanced between the needs of what level compaction needed to do, performance, and how it handles on the server. So big change there. But my general answer for people whenever they say, should level 0 be bigger, my answer is always like, yeah, I think it should be bigger. Well, this is the magic number, is 160 right now, and that'll be the new default. So some things are gone, and some of them you won't cry about. So, all right, super columns. Now, I guess if you've been in the Cassandra community for a long enough time, you'll hear the words super columns are evil, right? And I still run into them all over. Why are they evil? Well, just because of the implementation. It's not because of what they are. It's just the way that it's done. And what has been done up to this point is in the storage engine, the way that they're actually put onto the disk requires a big, fat deserialization read. And doing deserialization is a costly operation, and it's going to suck up CPU. It's going to suck up memory. And I've run into a lot of problems with Java heap issues whenever it's deserializing a lot of supercolumns. Well, when I say supercolumns are gone, it's just the implementation. So the API still exists for supercolumns. It's just the way that we've implemented underneath now. That it's no longer that heavy, big chunk of bytes sitting on your disk that has to be serialized. It's a much better, cleaner implementation. So the underlying storage engine supercolumns are gone. The API still exists. So if you're using supercolumns in your data model, it's not going to ruin the implementation. It will change things when it does compaction because it's storing it differently. But until then, you can still use it. It's a lot cleaner implementation from the storage engine. The other thing is we no longer allow row cache to live inside the heap. And going back to why we wouldn't, the Java heap right now is a premium. We want to keep that for the real-time running server application stuff that's going on, not for bulk storage. That's not what we want it to do. And it's always been an option. You can do on heap or off heap. Now we're just saying you can no longer put that on heap, only because that's going to be a potential issue that it would be a problem later on. It just doesn't make any sense. The off heap is just as fast, so let's just do that. So now it's no longer a part of it. It's no longer a default. We've removed some of the pressure relief valves as well. And if you've ever worked with a system that is under a lot of stress, let's say a really small server like an M1 large in Amazon, you'll see these error messages if it's really under stress, where it says flushing largest mem table at 0.75 or something like that. And these are just safety valves that were put into the system so that when you do start running out of memory, like you under-provision memory in the JVM, that there's these little safety valves that trigger that say, okay, I'm going to save the JVM and I'm going to start kicking things out. And it just never really worked the way we wanted it to, and it became more of an implementation problem. Since we have gone down this route of moving things out of the heap, it's just not as much of an issue anymore. If everything was still in the JVM, yeah, we would need these. But, you know, all the memory structures, the large memory structures are now leaving the heap. You know, it's like the move is on. And so it's just not as big of an issue anymore. That's one less thing you need to put in your operator guide. So you will see these three things, as flush largest mem table, reduce cache sizes, at and to. You'll see those gone from the YAML file. Just a heads up for those out there using scripts like Puppet or Chef or even Bash. If you're scripting your YAML implementations, you'll need to know that because that's no longer going to be there, and so there's nothing to change. So last slide here on operation changes. JDK 7 is now required. That's been one of those things, like we've been on 1.6, so JDK 6 forever, and now we've turned the corner on 7. So and it's required. You cannot start 2.0 with 1.6 with JDK 6. It won't work. And so just a heads up on that. If you're going to try, if you're going to be trying Cassandra 2.0, make sure you're using JDK 7. The other default change is vnodes is now the default. In 1.2, vnodes were an option. You could turn them on. You had to manually turn them on, but now it is the default consideration. So when you start it, you'll get 256 vnodes per server, and that's just the way it works in the YAML. You can turn those off. It's the opposite now. You can turn off vnodes and just use token assignment if you want, but if you leave it as is, then you're going to be using vnodes. The last big one here on the operations side, which I'm gonna save the best for last here, is the streaming overhaul. I'm personally very excited about this because streaming operations happen. I mean, when you move data from there's plenty of operations that move data: a repair, a move, a decommission, a bootstrap. All of these things create streaming operations. Streaming, of course, is when one node is giving data to another node. And that could be a pretty big operation. It could be gigabytes of data. Up to this point, they've been kind of hidden, for lack of a better word. It's hard to determine exactly what's being streamed and why. And so we're calling this Streaming 2.0. It's a pretty big overhaul. One of our committers, Yuki, did a really good job on it. I mean, it is going to change the way you do streaming, or you view streaming from an operations standpoint. So there's three big pieces to this. The control portion. The interesting facet to this is that streams are now grouped into these plans, stream plans. And stream plans have an ID, and they're traceable. So when something is going on, let's say like a bootstrap or a move or a decommission or something like that, you'll see these grouped up streams going, and you'll know exactly what they're for. So whenever the traceability is say, okay, well this stream plan has been put together for this one, and we know exactly where it's going and what data is being moved for this particular operation. And this is all exposed through JMX. And JMX will show you all the stream plans and what they're doing. Really, from an operations standpoint, gives you some great controls. The stream in and stream out, like what's coming and going and why. And that has not been there before. So if you have never used or never really looked at streaming, don't look now. Go look at 2.0 and be happy. The third part of this is the performance. We're now pipelining the streams. Before, when it would be one stream would run, it would be wait for an ACK and then do the next one, wait for an ACK, do the next one. That ping pong could get pretty heady. And so now every one of these streams are pipelined into a single connection. It's going to be a lot more efficient for that, especially when you have a lot of little files that have to get moved or a lot of little things that need to get moved. You don't have to wait for that ACK every single time. So streaming has had a nice little overhaul, and I hope this will make things better. As your cluster gets larger, you're going to have better control and better performance with that streaming operation. So that's it. I'm going to put in the shameless plug. So I'm going to be at Cassandra Summit in Europe in October, we'll see, 2 weeks from now. And so that's in London. We have quite a lineup going. It's a one-day event, but I just want to plug this part of it. I'm going to be doing the next talk in my data modeling series. It's focused around Cassandra 2.0, but I'm going to be doing data modeling around that and more data modeling examples, of course. But I want to show you some of the things we saw here in this talk about Cassandra 2.0. You know, there are some CQL changes. I want to show you some examples of how it's going to make your data model better and how you can really amp it up, you know, using the exists, using aliases, that sort of thing. So if you can't make it, I know not everyone's going to drop everything and go to London. Of course, the videos will be online. I will have slides online. You can watch it. You watch my Twitter. I'm at Patrick McFadden. If you want to follow me, please do. Lots of updates going on out there, and I'll be putting that out as soon as I'm done. So that's it.
Thank you very much, Patrick. Looking forward to London as well. It'll be a great event. So if you possibly can make it. Day one training is full up now. We've added an extra training day on day 3, which is Friday the 18th, and there are still a couple of spots left for the actual summit day. Okay, buckle in. Buckle in.
We have questions, don't we?
We do. We have
quite a few.
multiple questions. Should the column used in the new if condition of an update statement need to be part of the secondary index column?
Not a secondary index column, but part of the partition column, yes. And that would be part of the primary key.
Okay, so
it wouldn't be a secondary index.
Great, and follow-up here. Does Cassandra have a concept called partition similar to Oracle for a big table? If so, what is the feature named as?
Okay, well, that's a big data modeling topic. It's not the same as a partition in Oracle. Oracle partitions are taking a group of rows and moving it into its own domain, so that, you know, the separate query domain, different parsers. It tries to break up the storage engine underneath. And I mean, there's a lot of concepts around partitions in Oracle. I mean, I remember doing a lot of those just for performance management. I guess the simplest answer is you kind of get that by default with the way that Cassandra works. And I would encourage you to go look at some of my data modeling talks. But the way that Cassandra stores data from the storage engine and then the way you build your data model is the primary key is really how you build your partitions. But those partitions put you in a certain, those put you on a locality, meaning it's going to a certain server. So you get somewhat the same benefit as what like Oracle partitions do, or MySQL and SQL Server, they all do partitions, but it's the same type of benefit. It's just a different implementation. And so that's my simple answer for this one. It could turn into a whole webinar if I guess, but.
And Patrick, you've referenced your data modeling videos a couple of times. Where's the best place to go find those?
Oh, Planet Cassandra, of course. Yeah. Yeah, okay, there's 3 of them out there, so and it's good to watch them in series if you can. There'll be 4 soon.
Rick asked, does the reworking of the supercolumn implementation mean that it's reasonable to continue using supercolumns?
Oh, I knew I would get that question. Is it reasonable? I mean, this is what I would say about supercolumns. There are changes coming in 2.1 that will make supercolumns look really silly. And it has to do with the way we do collections, and I would actually encourage you to use collections. From a programming standpoint, from using CQL, supercolumns, of course, are not supported in that regard, but using collections are. But the enhancements coming to collections with user-defined types and nested collections, and this is in 2.1, and this is coming pretty soon, then those changes will make supercolumns look, like I said, silly, because it will give you a programmatic interface into what you're trying to do with supercolumns anyway. We've taken the pain out of supercolumns right now, but you should really look at kind of the way forward. And we don't want you to pitch supercolumns out of your data model, because it's not supported right. We're not going to just deprecate it and remove it, because we know there's a lot of data models out there that are currently in production that have it. So it's compatible. but think about the future and a better way of doing things, and that's where we're headed.
So speaking of compatible, Yogesh asks, is Cassandra 2 backward compatible with 1.2? What's the best way to migrate from 1.2 to 2.0 in a production cluster? And do we need to run a repair and cleanup on all the nodes when we add new 2.0 nodes to a 1.2 cluster?
No, actually the upgrade path is a lot cleaner. We don't even have to run upgrade SS tables, which is kind of a nice feature as well. So that's one of those new things in there that it's just better compatibility, backward compatibility with 1.2. It is not backward compatible with 1.1 though. So you need to go to 1.2 first, but once you're there, you can upgrade in place to 2.0. So there is a walk-up.
Okay, great. I can answer this one from Oliver. Timeline of 2.x in DataStax Enterprise release.
Soon.
Yeah, by mid-November, we will have that available in the market. And stay tuned for more info there. Wade asks, I don't understand the statements on bloom filters.
Okay.
Do they completely go away?
No. There is a, yeah, I knew that this was going to be a minefield, so let me see if I can step out of it. Bloom filters as a whole exist. Bloom filters exist per storage row, and that means that, when you look for a storage row of data, bloom filters are there to help you find the correct SS table. Those don't change. Inside the row, and this is probably why it's confusing. A lot of people didn't even know this, but inside the row, there's also some bloom filters going on as well to help you find data inside a row. And the fact that you didn't know that they're there points to the obvious reason why we got rid of them, because who cares? They didn't really do a lot. So no, bloom filters are intact. It's just a certain piece of it that no one really knew about or used.
Sanjay asks, Cassandra 2.0 is great, but how
But.
There's a but, though.
Yes.
There's a but. Basically, Hive and Pig work with vnodes. He's still hearing issues with vnodes and Hive performance. Any insight there?
I don't know about high performance. I did see, actually, on this morning on Twitter, I saw a lot of activity going on. Jake Luciani, who's one of our committers, pushed out a bunch of stuff about Hive. These are more DSE questions, of course, and 2.0 implementation that's going into DSE, DataStax Enterprise, is going to be, of course, supporting all of those features. I can't really comment on those exactly. I don't know all the details, but I know that there's a lot of improvements coming.
And there's a related question here from Wade. Will the next version of DataStax Enterprise support vnodes with Solr and Hadoop?
That's one of the things that is being improved right now, yeah.
Great. Rick asks, can you add nodes to an existing deployment without impacting the deployment?
Yes, that's the way it should work, is that you should be able to add, and there's a great demo that Netflix has done. They did it on stage where they added capacity to their cluster while running full load test, and it just got faster. You saw the performance increase and the speed increase. And that's what you want. You don't want to, adding a node whenever it's a linear scaling system should not bring your cluster down or be a problem. And if it is a problem, that's a bug that we'll fix.
So can you add nodes to an existing deployment without impacting the deployment? Should be no, you can't, because you'll positively impact the deployment. There is a positive impact there.
And with vnodes, the goal, of course, is that you can add them one at a time, which is a lot better way to manage your cluster overall. Always working on that. A lot of testing going on right now, actually, on some of those. There's some features coming in 2.1 that will even be better for some of those topics, especially when you're bringing nodes out of your cluster. So stay tuned for that. Impacting your cluster for operational events should be a no-op.
This is a great question. I think we probably don't spend enough time on here, but for people that may be new to open source projects and using those for your database system, maybe coming from a proprietary solution like Oracle.
Right.
Hear great things about 2.0. Do you recommend upgrading to it right now and running in production?
That's a great question, because the answer I like to give people is what's your capacity for risk, I guess, and what's your appetite for.
So he actually says he's risk averse.
Risk averse. Then stay conservative, and you can measure the risk, of course, because you have different tools to measure risk, right? Every feature that I talked about is completely open. We have our Apache Jira. So if you go to the issues.apache.org and you look at the Cassandra project, everything I talked about is all there. All the good, the bad, the ugly, what it was tested, how it tested out, everything. If there's a problem, bug reports, you can get a full list of the bug reports every single day. I get in my inbox, I get a list of all the bug reports that are being listed for Cassandra every day. And so I know what people are talking about, where the problems are. If you want to go in depth like that, I mean, you can do that. Or you can just hang back and be conservative. Maybe you want to just run 1.2 for another year. Great. I have people that I work with all the time that are still using 1.1 because they're just like, well, it works. I don't really need those new features, and I'm going to stick with that. Great. There are people out there that will download Trunk and run it in production, and I think that was Michael Kjelman's talk at our summit, where he was the day that 1.2.0 was released, he put it in production.
And we do have people running 2.0 in production.
Right. And
5-minute interviews will be posted pretty soon.
Exactly.
And one guy I asked, what was the impetus to running this in production? He said, I like to be reckless. He lives for the danger.
Exactly.
So.
Well, and some of these people are in community, very strong in community, like Michael Kjelman, he's a very strong community member. And he works for Barracuda. He works for a different company, but he wanted to put it into production and then help find any issues that were there, and he did. 1.2.1 was released maybe a week after he put it in production because they found an issue with like a compaction issue, and he helped fix it. And that's part of the community effort, and that we really appreciate that kind of contribution. Sometimes that is the contribution to open source.
So on that note, Jeff is referencing Kyle's Call Me Maybe article, which did find several problems with LWT. And he asked, are there fixes coming soon to address those? Maybe you can talk about, the beauty of open sourcing.
First of all, I worked a lot with Kyle. I think you probably saw that in his article. Kyle and I spent a lot of time on the phone. I really appreciate what Kyle did. Actually, we kind of asked him to do it because he has a keen mind at destroying databases, which is a great skill. And the part that I was a little disappointed about in his article, and he said he didn't have time, he ran out of time, but we did fix all those problems. That is in 2.0.1. So if you notice, he puts attribution at the bottom there to Alexi. Alexi is a committer, and he spent a lot of time with Kyle when he was going through those and verified the bugs, found the problems, and patched them, and that's great. But I'm not going to say that was a bad thing at all. This is open source. This is what it's about. We want to be transparent. I wish that he had said we'd fix the bugs, but I'm going to say it. We fixed the bugs. You can go look and see in Jira that they're there. But I appreciated his effort a lot, and I told him that. I'm glad he did that because he's got some skills at doing it.
Yeah, I think there aren't too many people that sit there and try to break databases.
At that level, yeah. And it was an edge case. Being able to put like the same timestamp on one column a lot, yeah, I hope people aren't doing that. But if you are, you shouldn't expect bad things, and so we'll fix it.
Nice. So Richard asks, if I wanted to play with installing Gemmalic, I don't know if I'm saying that right, Gemmalic, on a CentOS system, will Cassandra 2.0 report that it is found and is using Gemmalic somewhere in logs or startup messages?
I believe, I got to go back and look at the ticket, but I believe we were actually shipping with J.E. Malik, and so it wouldn't require you having it already. I'd have to look at the JIRA to make sure. You know what? Follow me on Twitter, and I'll tweet out whether or not it's in there or not. I can go look at the ticket again. Again, this is all in JIRA, so the final implementation is there. I don't want to just say one way or the other definitively, though. I'll go look.
If you can just add nodes, what happens to the replication factor impact when going from 1 to n nodes?
All right, so it sounds like you have kind of the concept of HDFS replication, where it's always going to be a certain replication no matter how many nodes you have. Well, Cassandra replication is all about the factor. So you're going to always have, like, let's say you have a replication factor of 3. That means there's 3 copies of your data in different nodes. When you add more nodes to the system, what you're doing is reducing the key space requirements per node. So it's responsible for less data. The data is still copied 3 times. It's just that in this case, when you add more nodes, each node is responsible for less data, so that data is spread a little thinner. Still 3 copies, less data per node, though.
Okay, time for one more. We're right at the top of the hour. What are the problems, if any, with mixing cache queries, for example, if not exists, with queries at other CL levels?
Well, all right, so every query has its own consistency level. So you're not going to be, the consideration probably be at application level. Do you have the requirement for if exists for one operation, let's say when you go to create this record, let's say a new user, then once it's successful, should your application still maintain that consistency level for all subsequent operations? My guess is probably not, because you had successfully completed that operation. Now you can move forward with your application knowing that since that happened, that user is now part of the system, and you can set other parts of your data. It's mix and match. If you really are paranoid about locking and having a race condition with a particular data that needs to be set, you set the consistency level per query, read and write. Insert and updates have this if exists, and then the reads are going to be affected by it as well. So that even goes with consistency levels of 1 or quorum. Every one of your queries is set independently or can be set independently. So that's why I'm really going to try to stress this in my next data modeling talk is like when or why. We need to understand this from an application standpoint. You heard me talk before. I like to talk about Cassandra, but I really want to talk about your application more because that's where it's really cool, right? And how do you use Cassandra so when your application is running and nice and great and everything, that it's going to work the way you want, and the database just becomes this boring part of your infrastructure. That's what we want. We want it to be boring.
Absolutely. Get your excitement somewhere else.
Exactly. Your database should not be the most exciting thing in your infrastructure.
Okay, well, Patrick, thank you as always. Stay tuned, actually. Before the next webinar that you see up on your screens here, we get so many questions during webinars, we never get time to answer them all. So we're actually going to bring in a panel, Patrick, Al Toby, and Matt Stump, 3 Cassandra ninjas with different areas of focus, and bring your questions to that Q&A panel. So stay tuned for details. Thank you, everybody, and have a great rest of your Thursday.